Hello and welcome back to our studies in physics. Last video we left off right here. Recall that these four principles up at the top are going to guide us in being able to draw graphs of other quantities versus time just given one of these graphs, one of these three graphs. So in the last video we started off knowing our velocity versus time graph and the initial position for the object, and we were able to draw the position versus time graph and the acceleration versus time graph from that one graph. And we're going to do now the same kind of thing, but first of all we're going to start with our acceleration versus time graph. So I like to draw the acceleration on the bottom. So we'll start with a graph of which we know information for the bottom graph, which is going to be our acceleration. So this is acceleration versus time, and of course this is along one line, so just plus and minus. Remember, drawing these kinds of graphs in two spatial dimensions requires three dimensions because you also have time in there. And then if you were to try and draw these graphs in three-dimensional space, that would require four lines, and of course that would be very, very complicated. So we're just going to deal with motion along one line when we look at drawing these graphs. So here's our acceleration versus time axes, and we're just going to draw something like this for acceleration versus time graph. So the acceleration is constant and negative. Okay, so this corresponds to, for example, a car that is accelerating along the negative direction and continuing to have a constant acceleration, so its change in velocity is constant. In order to draw the velocity versus time graph and the position versus time graph, we need to know what the initial velocity is, and we also need to know what the initial position is. So just to keep things easy, let's just make both of those 0. Okay, so here's position versus time graph. That's the positive direction. The negative direction, here's our velocity versus time. This is going to be the positive direction and the negative direction. So the additional pieces of information that we're going to be given besides this acceleration versus time graph is that the initial position is 0 and the initial velocity is 0. In other words, that at time t equals 0, on the velocity versus time graph we start right there, and on the position versus time graph we start right there. Okay, so how do we get information from the acceleration versus time graph to draw the velocity versus time graph? Well, remember, this acceleration versus time graph is just the slope on velocity versus time. So I have the value of the slope on the position versus time graph for all time. So the slope on the velocity versus time graph should be constant and negative. Remember, I can substitute slope on velocity versus time graph for the word acceleration anytime. So if I say the acceleration versus time graph is constant and negative, now I'm going to substitute what the acceleration is and say the same thing. So slope on velocity versus time graph is constant and negative. So if I start at 0 and I have a constant negative slope, what does that look like? And let's just draw these all the way up. So constant negative slope, there we go. So there is the velocity versus time graph, starting at an initial velocity of 0. Notice that if instead I had said the initial velocity is going to start at 5 meters per second or minus 5 meters per second, whatever, that would just simply have shifted my starting point on the vertical axis here for the initial velocity. That's all. The same shape stays the same. It would just have moved up or moved down depending on if I was at a positive initial velocity or a negative initial velocity. Okay, so now what about drawing the position versus time graph from this information? Well, now we have the velocity versus time graph. So again, remember, another way to say velocity is slope on position versus time graph. So the slope on the position versus time graph can be substituted for the word velocity anytime. So let's see if we can describe the velocity. Starts off as 0 and increases in a negative larger and larger values. So it becomes more and more negative, and the largest negative value at time t equals 0. So now substitute this collection of word for velocity, but say the same thing. So the slope on the position versus time graph starts off at 0 and becomes more and more and more negative, maximum negative at the end of the time interval. So the slope starts at 0, so that means the tangent line is going to be completely horizontal. And the tangent line or slope should be getting steeper and steeper, negative, remaining negative the whole time, and maximum negative at the end of the interval. So that means I should have a maximum negative slope here at the end of the time interval. So now let's just fill in between. And there is the position versus time graph. So now we have drawn both the velocity versus time graph and the position versus time graph, only being given the acceleration versus time graph. So we didn't use these two pieces of information, but notice that we can still apply them and look at the extra information we get. So the displacement should be the area under the curve on the velocity versus time graph. So this is the area under the curve right here, and notice that this is negative area. Negative area below the time axis should correspond to negative displacement. The object should be ending up more negative than where it started. And if you look at the position versus time graph, this is totally true. Down here are negative positions, and up here are positive positions. So the object starts at 0 and ends up at some negative position. So definitely a negative delta x for this object. The last one, the change in velocity, is the area under the curve on the acceleration versus time graph. So this area under the curve right here should correspond to the change in the velocity. Again, notice that this is a negative area. It is below the time axis, and so that means that the velocity at the end of the interval should be more negative than at the beginning of the interval. And is that true on our velocity versus time graph? Well, absolutely. We can see that we end up at a large negative velocity when we started at 0. So our velocity or change in velocity definitely negative. So you see how these four concepts can be applied, and drawing a graph or being given a graph and drawing the other two graphs and then translating this information and making sure that you say it a bunch of different ways and in a bunch of different ways is going to help you really integrate these concepts. Super important to understand these, and you'll see these throughout the semester. I will be asking you to draw these graphs, test 1, test 2, final exam. So please make sure that you spend some time. Getting this kind of information into your head is going to translate to making it easier as we build on these concepts. And remember, physics, every successive chapter is laid on the foundation of the previous chapter. So you have to have a really good understanding of these basics of kinematics to be able to understand the concepts that we'll be studying down the road. So we'll see you next time.